Example 2, find dy dx by implicit differentiation. 4x squared minus 7xy plus 2y squared equals 48. So they want us to go ahead and write the result of differentiating with respect to x and using the chain rule and the product rule on each side of the equation. So I'll start by writing up here derivative with respect to x, 4x squared, minus the derivative with respect to x of 7 times x times y, there's your product rule, plus the derivative with respect to x of 2y squared, and the derivative with respect to x of 48. So the derivative with respect to x of 4x squared is just 8x, right? The derivative of x would be a 1, and we don't have to continue to do anything there. Here we're going to have a minus 7, and I need to use the product rule on the inside. So it's the first x times the derivative of y with respect to x plus the second, which is y, times the derivative of x is with respect to x, it's just going to be a 1. Then I have to take the derivative with respect to x of 2y squared. That's going to be a 4y, and then the derivative of y with respect to x, and then the derivative of a constant is 0. So let me go ahead and write this out. 8x minus 7x dy dx minus 7y plus 4y dy dx. So we're going to make our choice. So it looks like it's going to be this third choice here, 8x minus 7x dy dx minus 7y plus 4y dy dx. Now I have to solve this, and remember this is equal to 0, so I have to solve this for dy dx. So I'm going to keep the terms with the dy dx on the same side. So that's the negative 7x dy dx plus the 4y dy dx. And these other terms will go to the opposite side by changing their signs, right? Because the 8x will be a minus 8x because I would have to subtract it. And the minus 7y would be a plus 7y. And so I'm trying to find dy dx, so I'll factor out the dy dx. That's going to give me a negative 7x plus 4y. That's equal to negative 8x plus 7y. And that gives me dy dx. Since it's being multiplied by this, I'm going to divide by negative 7x plus 4y on both sides. 7x plus 4y. And I get negative 8x plus 7y divided by negative 7x plus 4y. Now there are some other versions of this. For example, I could factor a negative out of the top. That would give me an 8x minus a 7y. And then I could apply that negative by moving it to the bottom. Because see, that's like a negative 1, and it can be in the top or the bottom. And that would give me 8x minus 7y over 7x minus 4y. Now this answer is completely acceptable, but I just wanted you to be aware that my math lab may go ahead and further simplify and get the expression 8x minus 7y divided by 7x minus 4y. It's just a little bit cleaner because it has the negatives factored out on both the top and the bottom. I could have just also done it this way. A negative 1 out of the top, 8x minus 7y, and a negative 1 out of the bottom, 7x minus 4y, and then negative 1 divides with negative 1. So that's probably a little bit easier way to see that. But in any case, our dy dx is 8x minus 7y over 7x minus 4y.